All right, let's keep on keeping on doing some more amazing problems. So we want to find the slope of the curve at the point. So we're only the slope, not the equation of the tangent line. But anytime you want to find the slope of the curve at a specific point, that's what makes it tangent, right? So here is our equation. 2 times x plus y to the 1/3 power equals y at the point 4, 4. That's a 1/3. I was looking at that and that looks wonky, doesn't it? Okay. All right. So I'm going to find a slope. So what are we doing? Derivative. And I've got two different variables. That is my tip off for implicit differentiation. I'm not going to tell you how to approach this problem. That's what you're supposed to know. But when you look at this, you see, oh, I've got two variables in the middle of my problem. That's my implicit differentiation. So let's do it right now. With this is not the product rule because this is just a coefficient. Let that sink in, right? This is just a number out front. Because it's just a number, I'm just simply going to do the chain rule, bring that in front. It's not a product, it's a chain. So I've got 2 times 1/3, keep the guts. And then remember, you're subtracting 1 from this. So that's going to give me a negative 2/3 times the derivative of the inside. Well, the derivative of x is just a 1, but the derivative of y is dy dx equals, and then I have a dy dx over here because it's that y again. Now remember this last time when we were working that other problem? Anytime you have this term and you've got this dy dx on the inside of these parentheses, you have to distribute. So I'm going to take this and I'm going to call this a 2/3, right? And distribute to both of those. So now we just algebra, right? Now we just algebra and isolate the dy dx. So I've got 2/3 x plus y to the negative 2/3, because it's times 1, plus 2/3 here, dy dx times x plus y to the negative 2/3 equals that dy dx. This term has a dy dx in it. This term has a dy dx in it. Because I just have this one term, I'm going to subtract this 2/3 dy dx minus 2/3 dy dx of x plus y to the negative 2/3. That goes, just writing and rewriting again, trying to isolate and algebra that down. X plus y to the negative 2/3 is now equal to dy dx minus a 2/3 dy dx and x plus y to the negative 2/3. Now I see I've got a dy dx in common and we can factor that out. 2/3 x plus y to the negative 2/3. Remember, when I factor out this dy dx, I've got two terms. You got to still have two terms. So that's a 1. Don't forget that 1. People do it all the time. Hang on to that 1. 1 minus a 2/3 x plus y to the negative 2/3. Okay. Get that try it again. Get the dy dx by itself. I'm going to do 1 minus a 2/3 x plus y to the negative 2/3 divided by 1 minus a 2/3 x plus y to the negative 2/3. That goes, that goes. Now, just because it makes me feel better, I'm going to write the dy dx over here on the left. And I'm going to write this as 2/3 x plus y. No, I've changed my mind. This is how I'm going to write it. Because look at what's happening here. Okay, so first of all, we can just look at this problem and say, holy crappanoli, right? How are we going to pull this bad boy off? Well, I've got a negative exponent here. I can't cancel these because of this minus sign. right? So these are stuck together. I can't take these out independently. You really want to, don't you? But you can't. But you can't. So, but I can look at this and say, this is a negative exponent. This is a negative exponent. I've got this complex fraction. Let's see how we can figure this out. So this is 2 over 3 times that x plus y, and now I make that to the positive 2/3. And I've got 1 minus 2 over 3 times x plus y to the 2/3. Now think about all those complex fractions we've worked with, right? When you were simplifying those rational expressions down with the definition of derivative, all that stuff. That came in handy, didn't it? Let's do it right now. So my common, I choked up there. My common denominator is this, because this is over 1. So I'm going to multiply the top by 3 times x plus y to the 2/3 over 3 times x plus y to the 2/3. Get some algebra going for me. And then I distribute that. So dy dx actually equals 2 over, now 1 times anything is itself, 3 times x plus y to the 2/3 minus 2. And look how much nicer that is. Right? That is so much nicer to try to plug this value into. Yes, if you can simplify algebra, learn it, love it. We get to practice so much in calculus, way more than you do in actual algebra. But we get to practice so much in calculus that we're good. Okay, now I've totally forgotten what we're doing. So let's squeeze it back down. Find the slope of the curve at this point, 4, 4. Okay, just the slope? No problem. We can do that all day long, right? I'm going to take dy dx and I'm going to evaluate it at the point 4, 4. Okay. 2 over 3 times 4 plus 4 to the 2/3 minus 2. Okay, just plug that in. 2 over 3 times, now remember what 2/3 is, right? 4 plus 4 here is 8 to the 2/3 power. That's power over root. So always do the root first. So the cube root of 8 is what? 2. Good. So if I know that's 2, 2 squared is 4. See that? The cube root of 8 is 2. And then 2 squared is 4. Minus 2. So 2/10 is 1/5. It's not bad, right? When you go to actually plug it in, it's really not that big of a deal. The kicker is getting all your algebra set up so that it's really not that bad of a deal that you can work with. Got it? Cool. Algebra, algebra, algebra. It's good stuff. Good, good.